Okay, over to you, Gareth.
Thank you, Sian. Thanks for the opportunity tonight to talk about the new curriculum and some of the changes that have been made into the new legislation. So I have a PowerPoint to share with you. Let me, first of all, for the people joining us live tonight, I'll drop it into the chat. So if you want a copy, a downloaded copy of the PowerPoint, you're welcome to click on the link in the chat. So next, let me see if the share screen works over here. So let's have a look. Shan, can you confirm that my PowerPoint thumbs up? Okay, great.
Yep.
Okay. So the title of the session is Developing the Mathematical Proficiencies. So let's begin. So I thought to begin with, I'd just put this slide up. It's a summary of all the legislation in the new curriculum for Wales. I haven't included everything, but it's kind of a one-stop shop for the content of the curriculum. So we're familiar by now, hopefully, with the first bullet point. We need to develop learners to reflect those four purposes, from ambitious, capable learners to being healthy, confident individuals. How do we do this? We do this through the 6 areas of learning and experience, mathematics and numeracy being one of them. The content is controlled by the statements of what matters. There are 27 of these in total, I believe, of which 4 of those come from the mathematics and numeracy AoLE. Now, 5 of the AoLEs have these common principles of progression. The first one there is increasing effectiveness as a learner. The odd one out is mathematics and numeracy. We have our own mathematical proficiencies, and I'll talk in the second half of today's session of how we could develop these in class. There are some things we need to teach. We have to teach, for example, religion, values, and ethics. And throughout all of our lessons, we need to remember the 3 cross-curricular skills, the literacy, the numeracy, and the digital competence. So that's a kind of a summary of what's in the new curriculum. Now, let me take these one by one next. So I'll start with the 4 purposes, which I've highlighted there, hopefully in red. Now, I was lucky enough to be part of the team developing this new curriculum. There was a great team of teachers all over Wales in all sectors meeting monthly or more often towards the end to write the statements of what matters and so on. We did in our meetings discuss in length these 4 purposes and how in particular mathematics and numeracy can contribute to learners reflecting these 4 purposes at the end of their education. Now, this slide here is kind of a summary of our discussions. Now, I could take the entire hour today talking about the 4 purposes. I'm not going to do that. I'm going to concentrate on one of them, in particular, the one that we see left here, the ambitious, capable learners. But just to note here that this list here isn't meant to be a definitive list. It's meant perhaps to simulate discussion in perhaps a departmental meeting in the secondary school, or perhaps a numeracy coordinator could lead a discussion in primary school on these 4 purposes. So let's look at the top left, as I say, the ambitious, capable learners ready to learn throughout their lives. How can we, in the mathematics and numeracy AoLE, get our learners to reflect this? Well, the first bullet point there in the top left is developing a positive attitude towards the subject. Now, unfortunately, in this country, we still have people more than willing to say, I can't do maths, or it's socially acceptable to say, oh, yes, I was never any good at that at school also. Contrast that perhaps to people who are less willing to say, I can't read, and maybe you can see the difference there. I see this oftentimes in parents' evening, where somebody hasn't had a glowing report, and perhaps the thing we hear is, oh, that's okay, I wasn't good at maths either. So it's those negative attitudes being perpetuated either by parents, as I say, or it could be staff members in our schools, people who aren't as positive towards the subject. Of course, it could come from the learner themselves as well. I think developing this positive attitude and really tackling these negative stereotypes, if you like, in parents' evening through communication with staff members, so that everyone's singing from the same hymn sheet, that it is important the way we talk about mathematics with the young people that we have in front of us each day. We could do that by trying to establish a lifelong interest in mathematics. That's the second bullet point there. To take interest in things that appear in the news. For example, we are in the middle of a pandemic, and more or less every news bulletin contains the latest statistics about vaccinations, about cases and so on. So there are natural places to discuss mathematics, going to the supermarkets, going on a trip, distances, times and so on. So taking those opportunities to discuss the subject whenever the opportunity arises. Next, we have a bullet point here, encouraging learners to be curious, open-minded, willing to accept mistakes and learn from them in the mathematically purposeful way. So this kind of talks about the culture in the classroom. What happens in your classroom if somebody makes a mistake in mathematics? How is that dealt with by yourself as the teacher? How is that dealt with by the other members of the class? Now, perhaps we could develop what I would maybe refer to as a culture of error, where it's okay to make an error in the classroom, that it's not seen as something that's negative. Maybe we celebrate errors and we ask why have those errors arisen? Is there a misconception there that other people in the class may also possess? Recently, I've taken this on myself. When I make a mistake in class, I hold my hands up and I thank the person in the class who often is more than willing to correct me. But then, so that errors become a part of experience in the mathematics classroom. There isn't a stigma attached to them. People are willing to give forward their ideas, their answers, without the fear of being wrong. And then the fourth bullet point here, developing metacognition so that learners know which steps to take to improve performance. So that learners, in other words, know where they are, know their strengths and weaknesses, and know what we need to work on. Now, perhaps technology could play an important part here. We have the national numeracy tests, which learners do in a short period of time, and there is feedback given from those tests on strengths and weaknesses. But there are also other websites. Personally, here in school, I use the diagnostic website, the diagnostic questions website, I should say, which gives detailed feedback on different areas of mathematics. And this is very useful during parents' evening when I get the question, so what does my son or daughter need to improve on? I can then show it on the screen in detail. So as I say, this isn't meant to be a definitive list. It's meant to facilitate discussion in a departmental meeting or in any setting, to be honest. And as I say, have a look at those other bullet points for the other three purposes, and please discuss them in your schools. So that's the first slide there. If I now go back to the original slide I had, this time I've highlighted in red those 6 areas of learning and experience, and then I talked about those 27 what matters statements. Well, in mathematics and numeracy, we have these 4 what matters statements, and there is no surprise here that we're still talking about number, algebra, geometry, and statistics. In fact, when we were developing the curriculum, we looked at high-performing countries all over the world, from Singapore to Finland, to Australia, to Canada, and there was an international acceptance of what mathematics is. This was not something up for discussion, it seems. Every curriculum had some iteration of number, algebra, geometry, and statistics. So that's the good news. There isn't a lot of change in the content itself. That, as I say, that seems to have been settled. But that's also a risk in the fact that some people may say, well, there's not a lot of work that we need to do in mathematics and numeracy. We can continue along the same path that we've always trodden. And there's the risk, because in this new curriculum, we do have the new proficiencies, which I will talk about in a minute, and they will influence the way in which we teach mathematics and numeracy. That'll be the biggest change, I feel, not the content itself, but the way we go about teaching. So if I go back again to my list and look this time at the bottom at the mandatory components and those cross-curricular skills, every teacher in Wales should be familiar with these cross-curricular skills. In the new numeracy framework, we have these strands. So there are 4 strands like the old framework. If I go up from the bottom this time, we have data handling, geometry, and number. And if you are familiar with the current numeracy framework, these will be very familiar to you. The big change, as I'm saying more than one time tonight, is that first strand, which is developing mathematical proficiency, which introduces here the conceptual understanding and so on. Now, perhaps at this stage, I've got a next slide here, which tries to show the difference and the similarities between the current numeracy framework and the new one. So if you bring that slide up, so what I've overlaid here in red is the contents of the old numeracy framework, or if you like, the current numeracy framework at the minute. And again, going from the bottom, we see that there's been an element of rebranding. So the new framework has data handling, whereas it used to be called using data skills. And then drilling down there, we have collecting data, representing data, and interpreting data, taking the place of collecting and recording, presenting and analyzing, interpreting. So again, the content itself is very similar. Same with geometry. We're still talking about measurement, shape and space, position and angle. Same with number. We're still talking about the number system, relationships within the number system, calculation, and then financial literacy is the title there instead of managing money. Again, as with the current framework, algebra does not appear in the cross-curricular framework, but the other 3 what matters statements do. So the first bullet point there is what I'd like to concentrate on for the next couple of minutes. So the developing mathematical proficiency, which is the conceptual understanding, the logical reasoning, the fluency, the strategic competence, and then communication using symbols. Now, of course, written in the curriculum, we have to give them an order. So in the curriculum document, conceptual understanding appears first, but that is not to say that that is more important than the other 4 proficiencies. These should be thought of as being on the same level. And the picture there illustrates, hopefully, that they should also be thought of as being interlinked or intertwined. So in some tasks or in some lessons, if you're trying to map these proficiencies, they will be totally apart. They will be able to be discerned into different boxes. But in other lessons, they will melt more into each other. So they'll be intertwined. It'll be difficult to see the difference between the 2 or more of the proficiencies. So let me go back one final time to my summary slide. As I said earlier, the 5 other AoLEs, the ones that are not mathematics and numeracy, have these common principles of progression, things that make pretty much common sense as a learner, I should say, makes their journey through school. We should see increasing effectiveness as a learner. We should see increasing breadth and depth of knowledge, and so on. The only outlier is, as I say, is the mathematics and numeracy AoLE. Our principles of progression are these mathematical proficiencies. So let's delve into these, and let me give you a calculation task. So this may be something that you could try in class tomorrow or whenever you next teach mathematics. So if you have a pen and paper handy, that would be useful at this stage, or a mini whiteboard, or whatever you have. The back of an envelope will do. So what I have here is a grid, and as you see, there are 4 squares forming the grid. And in the calculation task, the first step, I'm going to get my biro here in PowerPoint, is to put 4 single digits into those 4 squares. So for example, let me try and put 3, 7, 2, and 5. So once we've decided on the 4 digits, the next task is to look at the digits row by row and to multiply the digits in each row. So my first row is 3 and 7. If I multiply 3 and 7, I obtain 21. The second row, I have 2 and 5. Multiply those together, and I have 10. I do the same then with the columns. In the first column, it's 3 multiplied by 2. That's 6. And in the second column, 7 multiplied by 5 is 35. Next step is to look at those 2 numbers, which I've obtained from the rows and columns. So my 2 rows, I've obtained 21 and 10. If I add those together, I obtain 31. And if I do the same with the 2 numbers from the columns, 6 add 35 is 41. And then there's one final sum to do. These 2 numbers, I've obtained 41 and 31. The positive difference between these 2 numbers is 10. So for my 4 initial digits, 3, 7, 2, and 5, the final solution or the final number I obtain is 10. Now, I'd like to ask you now to have a go at this task, and then I'd like you to share in the chat your solution. So let me stop sharing the screen just for a minute so I can access the meeting chat. So for the example I just gave you, if I go into the meeting chat, let me just get that up here. So if I can ask you to write down the numbers like this. So my one was 3 and 7 in the first row, and then 2 and 5 in the second row, and then gives 10. So if you have a look at what I've written in the chat there, and I'll reshare my screen now so to get that method up back on the screen. So I've written in the chat 3725 gives 10. So if I can ask everyone to give it a go and to give me a solution in that format. So what are the 4 numbers that you started off with, and what was the final positive difference? Now, if you're joining us live, you'll be able to see those in the chat. For the benefit of those watching on the catch-up, let's say, let me read out what I see in the chat. So I am seeing, it's a lot of them, I'm going to have to scroll right up here. So 6394 gives 12. 3624 gives 4. 2874 gives 2. And then let me scroll back down. So I have 4253 gives 3. There's 14 in there. 2689 gives 14. And then 9431 gives 22. And so on. So this is what I would call a low floor, high ceiling task that everyone can start off with. So everyone hopefully can think of 4 digits. And then as long as we've met the concepts of multiplication, addition, and then subtraction, we can obtain a positive difference at the end, and we can start to explore. So in class, perhaps I would give this the instructions as I've given, and then just ask the class as I've asked you to explore, maybe writing down on the whiteboard the different solutions. And then again, if you're joining us live, if you scroll up now, if you have a look at those solutions that everyone's given, perhaps I would then ask the class, okay, so I obtained a positive difference of 10. So what other positive differences are possible? So what's the lowest positive difference I can obtain? So I'm scrolling down. I can see a positive difference of 2. Can anyone beat 2? There's a 1 right at the bottom. So I think 1 is the winner at the minute. 4325, I can see, gives 1. Then I could ask what's the highest positive difference. And then perhaps I could go into special cases. So if you look at people who have obtained a positive difference of 3, if you have a look at the numbers here, so I'm seeing 1, 2, 3, 4 gives 3. And is there another one of 3? Yeah, someone else with 1, 2, 3, 4. And there's another one, 4, 2, 5, 3 gives 3. Now, it turns out in this particular task, if you choose 4 consecutive numbers, then that gives a positive difference of 3. So maybe that could be something to explore with your class. Ask them, first of all, when does a positive difference of 3 occur? And then perhaps we could go on to prove that it's always a positive difference of 3. Now in primary, proving that it always gives a positive difference of 3 would mean, remember that I said we need to start off with 4 single digits. So the different combinations there would be 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 6, and so on. What will be the final one? 6, 7, 8, 9. So to look at those different possibilities and do a proof by exhaustion, that we look at all the different possibilities, and yes, we agree that the positive difference is always 3. If I go back to my PowerPoint here, so perhaps then at the secondary setting, this would be nice at GCSE level. If I create a grid with 4 consecutive integers, so a plus 1, a plus 2, and a plus 3. And then it would be a nice bit of algebra here. So in the first row, I have a multiplied by a plus 3, sorry, by a plus 1. Then I'd have a double bracket, a plus 2, multiplied by a plus 3, and so on. If I go on with that train of thought, multiplying out with algebra, taking that positive difference, you will find that you finish with a positive difference of 3. So that would be a good exercise at secondary level in expanding brackets. I don't know if anyone's had a positive difference of 0. I don't think anyone's had a positive difference of 0 in the list, but maybe that would be my next question. When does a positive difference of 0 come in? And the clue then would be to look at repeated digits. So for example, if I tried 1, 1, 1, 1, that would give a positive difference of 0. And then it would be a question, well, how many repeating digits do I have? In what positions do they need to occur? And then all the way to A level, which is beyond the curriculum, of course, perhaps then I would talk about a general case, A, B, C, D. And what happens in that case is a nice bit of factorization that comes in there. And actually, there is a nice check for this task. I mean, I must confess here, I didn't do the check correctly with the Welsh presentation last week. So let me try a bit better this week. So if I'll have a look at my original grid again, 3, 7, 2, 5, and if I highlight the numbers in the diagonals, and then if you look at the positive difference between these numbers in the diagonals, well, for my 3 and 5, the positive difference is 2. For my 7 and 2, the positive difference is 5. And if I multiply these two numbers together, then I obtain the 10 I obtained beforehand. So perhaps someone could have a look at why that is the case. Again, in a general case with algebra, perhaps. So as I say, it's a low floor, high ceiling task. Everyone can start, and it leads to different places. So again, lots of different questions, lots of different things to explore here. Now, if I move on, and now let me think of how the mathematical proficiencies are related to this particular task. So again, the 5 are conceptual understanding, logical reasoning, fluency, strategic competence, communication using symbols. Now here perhaps is a possible template to use when planning a lesson or a set of lessons, a unit topic, for example, on a particular topic. Now, in the middle, there is space to put in whatever we are teaching at the minute. So I've talked about this task today. So let me just come out of this PowerPoint at the minute so I can type into these boxes. I'll keep my annotations. So in this particular task, if I start in the top left here, conceptual understanding, what concepts do I want my learners to understand here? Well, for example, I would want them to know the meaning of positive difference. I talked about that blue number there being a positive difference, which is quite subtly different to subtraction. So if you always do the number on the right, take away the number in the bottom, you're not always going to get a positive number. So there's a subtle difference there between subtraction and positive difference. So that's maybe a concept that we could develop. Fluency, bottom right. What would I want my pupils to be fluent in, perhaps before reaching this task? Well, this is a task, of course, which requires us to multiply to single digit numbers. My apologies beforehand if I misspell anything tonight. Addition, and then subtraction. So those are the core skills, if you like. This is a purposeful practice task as well, which the multiplication, the addition, the subtraction is hidden, if you like, between a task that we use to do an investigation. Logical reasoning, well, there, for example, I could talk, when is the positive difference? 3, and then we can reason out that we have 4 consecutive digits in this instance, and then we could maybe reason, well, what's the lowest difference? That will be the 0. When does that happen with repeated digits? And then what's the highest positive difference? I'll leave you to explore what's the highest possible difference. Top right, communication using symbols. Well, here it's about how we set out the work. So the way I've asked you to set out the work, I've not used any operators at all. There are any multiplication symbols or addition symbols or subtraction symbols. So it's about creating a shared understanding of what this task is about. Perhaps a good way of introducing the task would be just to put up on the screen what you see in the middle there and asking the learners to decipher, okay, what's going on here? Where does the 28 come from? Why is that 40 there? Why is that 10? So that could be a good way of introducing the task. Of course, tonight I've explained it to you kind of step by step, but can people reason out perhaps why this ends up with 10 and not with something else? So communication using symbols, so how the task is laid out, and more generally, how to present a, well, I don't know if a solution is the right word here, but in my example, it would be the blue 10. So I asked you in the Zoom chat to present it in a specific way, the 4 digits, and then the positive difference. So it's about how we present our work. Now, strategic competence here, well, what's the strategy here? Perhaps there isn't a strategy here, perhaps there is. I mean, we don't have to have something filled in with every task. And perhaps we started off by a bit of randomness. We just picked 4 numbers from thin air. But then perhaps the reasoning comes in when those questions kick in. When is it 3? When is it 0? What's the lowest? What's the highest? Then perhaps we start to think of a strategy. Okay, what different combinations can we use? But perhaps there isn't a ready-made off-the-shelf strategy to use specifically in this particular example. Okay, so that's me kind of brainstorming by myself here how I would map the proficiencies to this particular task. I'd also like to look at a different one if possible. So let me change the slide now to show you this one. So hopefully it's big enough for you to read. So I have in the middle this time a shape which is in red, and the question is calculate the area of this shape. So before I go into to talk about any proficiencies, let me just consider how I would actually answer this question. So hopefully, if I press this button in the bottom here, can we see that? Sian, there we go. Diolch, Sian. So as I say in Blue Peter, here's one I prepared earlier. So, okay, so what's the area of this shape? Okay, so how do I tackle this? Well, there's many different ways of starting, but let's say I decide to split the shape like this. Let me call this rectangle here A, and then let me call this one over here B. Okay, so given that we know how to find the area of a rectangle, for rectangle A, I would need to multiply 7 by 8 to obtain 56. And then for rectangle B, oh, okay, so it's not quite as clear cut. Let me have a look now. Okay, so this piece at the bottom here is 10 meters. So this piece at the top is 7 meters. Okay, 7 add 3. Okay, this must be 3 here then. 7 add 3 gives me the 10. And then this length here, well, I've got to take a bit of care here. This is in centimeters, whereas the others are in meters. Okay, so I need to recall a fact here that there are 100 centimeters in a meter. So that's the same as 2 meters. Now, once I realize that, I can then calculate the area of rectangle B. That's 3 times 2, which gives me 6. And then I need to add these, and hopefully make a mistake here. So 62. Okay, I haven't quite left myself enough space here, but I need to put the units in. So let me squeeze in meters squared in the corner there. So that's perhaps how I would go about answering that question. Okay, let me return now to my planning sheets for the proficiencies. Okay, so how do the proficiencies relate to this calculating the area of the shape task? Now, concept, first off, if I edit this box here, I think obviously here we need to know what's the meaning of area. We know that there's confusion between area and perimeter. So if it asks for the area of a shape, then we need to know the meaning of the area. If you like, the carpet on the floor. So notice in this particular example, the dimensions are such that it could be the floor, perhaps of a classroom. So we could talk about how much carpet we need to put on the floor. But also, the question is calculate the area of this shape. Now, what is this shape? So would it be better, or could we link it to another area of the curriculum if we notice that this shape has 1, 2, 3, 4, 5, 6 edges? So what we are calculating the area of an irregular hexagon. So are we making that link at the minute? If we're asking for the area of the shape, do we know what's the name of the shape? And how can we recognize that it is an irregular hexagon? So we're making links to other areas of mathematics. Strategic competence, if I go down the left here, well, how to split the shape. So in my particular solution, I split it with a vertical line. I could have chosen to use a horizontal line here, and then I'd have a rectangle in the top and a rectangle in the bottom. I could even have considered an enveloping rectangle. If I try and add this here, the enveloping rectangle would be the one with dimensions 8 meters and 10 meters. I could work out the area of that enveloping rectangle and then take away the area of this rectangle over here. So that's a third method perhaps. So how to split the shape and then use an enveloping rectangle. So be aware that there are different strategies that can be used to answer the question. And of course, that would be a good checking mechanism as well to try a different strategy. And hopefully it leads to the 62 meters squared. Logical reasoning. Well, again, if I go back to my mini whiteboard here, I had to reason that this length here was 3 meters. So without that piece of reasoning, I would have been stuck as to how to find the area of rectangle B. So reasoning, edit this again, that the length of the smaller rectangle in my solution is 3 meters. And then communication using symbols, top right, let's have a look here. So I would note here using the correct unit in the solution. So that would be, in this case, meters squared. And also mean correct usage of the equal sign. So let me flick back to my solution here. So I've set it out carefully. So I've got the area of rectangle A and then the area of rectangle B beneath. So that leads to an easy addition then to give 62. Now, an incorrect usage of the equal sign would be to write something like this out. If I started with area of rectangle A, 7 times 8 is 56. And then, okay, I can do in my head that 3 times 2 is 6. So I need to add that on. So let me add that on. 56 add 6 gives me 62. And this is what I mean by incorrect usage of the equal sign, because the left-hand side here is 56, but the right-hand side is not 56. So we've broken the equality of this number equation. So it's just being aware of how learners set out their work and correcting this in their book when you see it. So correct usage of the equal sign. And then finally, the fluency. If you like, what are the prerequisites we need to know beforehand? Well, multiplication. If I don't know how to do 7 times 8, I'm going to be stuck there. Finding or calculating or determining the area of rectangle, and also addition. So these are the skills that we need during the question. We need to be fluent in these skills in order to be able to access this question with a minimum amount of cognitive load. If I'm thinking too hard about how to multiply 8 times 7, then oftentimes what we'll see is that memory capacity has been used to do 8 times 7, and oftentimes we'll see the meter squared missing from the end of the solution. So it's having that capacity to have things fluent enough so we are able to concentrate on the constituent parts of the question. Also, I could have talked here about, well, is this really a shape with right angles? I've kind of assumed that. Maybe that would be a question I would want someone to ask. Well, do we have 90 degrees here? That is this really a rectangle without knowing that these are 90 degrees? And perhaps it's not going to be exactly 62. So that's maybe a line of thought that we need to take onwards. So that's kind of like how I'd plan this task out around the proficiencies. So last week I talked about a lot of your schools will have fantastic tasks in mathematics already in place. Do we need to rewrite all of those for the new curriculum? No, we don't. If you have a fantastic task, something that you've tried throughout the years, you know that it works, by all means continue to use that, because as I say, the content has not changed. What you do need to consider, on the other hand, is what extras can you talk about during particular tasks. So for this area task, it would maybe be, whereas maybe in previous years, not recognizing it as an irregular hexagon, maybe mentioning that, making the link to that terminology that they've maybe encountered before. It's being aware of, when I'm marking the work, the correct usage of the equal sign and correcting that, making a note of that, and dealing with that head on. It would be looking at different strategies and not using one and sticking to it. It would be looking at the enveloping rectangle. How does that lead to the correct solution? So it's kind of like I've been watching a bit of MasterChef recently on the television, and there was someone, I think last week, in one of the tasks had to do an invention test, and they did beans on toast. So I'm thinking, well, in the old curriculum, if I was doing beans on toast, then perhaps I would do it as I do at home, just open up the tin, just shove it in the microwave, 4 minutes, 2 pieces of toast in the toaster, and that's it. Maybe that would be an old lesson in the new curriculum. But maybe in this new curriculum, We need to think about preparing our lessons for MasterChef. We need to look at the presentation. We need to look at the flavorings, perhaps. We need to look at things that go around it. So we do have our tasks in place. I would hope so. Across North Wales, there's lots of good practice, lots of fantastic tasks in place. It's just looking at how we embellish those, how we improve them a little bit using these proficiencies. What are the things that are perhaps missing at this particular point in time? So it's evolution, not revolution, perhaps, in the new curriculum. Right, so let me have a look at the clock. I have, I think, 18 minutes left. So let me use the time that I have left just to recommend perhaps some other resources for dealing with these proficiencies. So the first one, I'll look at the proficiencies one by one now. So let's look at conceptual understanding. So here's a website you may be familiar with, may not be. So it's moresameless.co.uk. So the kind of task you see on this website is like the one I've got in the middle of the screen here. We have two concepts. I have perimeter and area, and then there's something in the middle. So here there's a purple shape, and then we have to fill in the other part of the grid, considering the concepts under consideration. So here, let's see if I can remember how to do this. Let me get the snipping tool. Let me take a picture of this question. And then let me drop this into Paint if I can. Right, okay. So here's the task. So in the middle, there's a purple shape. And then the area, if I count squares, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 unit squares. And then the perimeter starts top left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 units. Okay, so the task is to fill in the other parts of the grid. So if I stay in the same row, so if I stay with equal area, but go to the left, so my perimeter is less, then I'm looking to create a shape here with the same area, 11 squares, but where the perimeter is less than 18. So perhaps I could start to create the shape similar to what was already there. But instead of putting that final block in the top row where it is in the middle, maybe I could move it to there. So now I have a shape with the same area, but I think you'll find then that the perimeter will be less than 18. Staying again in the same row with the same area, and then going to the right. So again, I'm looking to create a shape with 11 squares. Ooh, I'm going to have to count them now and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, there we go, 11. I was lucky. But that, I think, has a greater perimeter. So these kind of tasks force learners to really think about the conceptual understanding. They really need to understand the meaning of perimeter and area in order to complete this task. It's a great one to try in a departmental meeting. It's get your staff members or get members of your primary school to have a go at this. You really find yourself thinking about the meaning of area and the meaning of perimeter when you do this. And of course, if that leads to not having that area perimeter misconception, that's positive news. So that's the website, moresameless.co.uk. You can have a look at. Next, let me move on to logical reasoning. So the website this time is mathsfens.com. This one is created by Craig Barton, which many of you will know as being the author of How I Wish I Taught Maths, a very good book, recommended by lots of mathematics teachers. So here's one of the tasks on this website. So it's set out as a Venn diagram. So here I have 3 circles. The purple is at least one pair of parallel sides. The blue is at least one square angle. The question is, think of a quadrilateral that could fit into each region. If you think a region is impossible to fill, explain why. So here, for example, I could ask the class, right, can you think of a quadrilateral? And what do we get 9 times out of 10? We get perhaps a square. So let me try and put a square in the corner here. Forgive me for not using perfectly straight lines with my mouse here. That's not too bad, is it? So where does that fit into the Venn diagram here? Okay, are we in the purple circle? Do we have at least one pair of parallel sides? Well, if it's a square, then we are parallel top and bottom. And we are also parallel in a different direction, left and right. So yes, we're in the purple circle. Are we in the blue circle? Do we have at least one square angle? Well, yes, by definition, a square will have 4 right angles. So that's correct. We are in the blue area. And then are we in the green? Are all sides equal? Well, yes, again, by definition, a square will have 4 equal sides. So the square would fit here, right in the middle, into region G. I could then, of course, go on to discuss where does a rectangle go, where does a rhombus go, where does a kite go, and so on. And perhaps once we've done that, if we have any spare regions left unfilled, well, can we think of a shape that would go into that region? If not, can we justify why we cannot fill that region in? So there are hundreds of these tasks on the Maths Friends website. Some of them, like we see here, with 3 circles, some of them with 2 circles. So again, I would recommend that website. Fluency is the 3rd proficiency on my list here. So Don Stewart, the late Don Stewart, unfortunately, has a great website. You see it there, donstewart.blogspot.com. So this is a treasure trove of activities. If you've not used this website before, you are missing out so much. It's actually the one from previously in this presentation with the 4 squares in the grid. That was taken also from Don Stewart's website. So here's another one. It comes as an investigation. So this time we need to place the numbers 1 to 6 used once only in the circle. So let me do that. Let me say 2, 1, 3, 6, 4, 5. So place the numbers 1 to 6 in the circle. Then we multiply in pairs to fill the squares. So top left, 6 multiplied by 2 is 12. Then 6 multiplied by 1, 6 multiplied by 3. 4 times 2, 4 times 1, 4 times 3. 5 times 2, 5 times 1, 5 times 3. Okay. And then the instruction is to add the 9 numbers in the squares. Well, here, thinking of a strategy, I'm going to add them row by row. So the first row, 12 add 6 is 18. Another 18 gives me 36. Second row, 8 and 4 is 12. Another 12 is 24. And then I have 10 and 5, which is 15. Another 15 gives me 30. And then I've split the task of adding up the 9 numbers in the squares into 3 sets of 3. And because I've done it row by row, I can then do a nice column addition here, adding up the units. 10 units. I'll carry on the 1, and then the 10s, 3, 4, 5, 6, 7, 8, 9. So that's a total of 90. Well, the investigation is this. There are only 5 different totals possible. So can you work as a class to find out what they are? So again, this would be a low floor, high ceiling task. So as a whole class, people could work out, okay, there's 90 there. What are the other 4? So what's the highest total? What's the lowest total? And then again, perhaps later on in secondary school, I could ask people to justify why only 5 totals are possible. So here we would start off perhaps with a bit of algebra, starting off with A, B, C, D, E, F, and then multiplying, for example, top left would be A multiplied by D, and then working out, okay, if you do a bit of algebra to add those up, what are the different possibilities? This leads nicely even to A-level material with combinations and permutations. There are actually 720 different permutations here, but of course, not all of them will lead to the same total, only 5 different totals. Can we justify that? I've used this this year with year 12. It's a nice little A-level task. So that's a bit of fluency. We do a purposeful practice here. So it's an investigation, but people are doing a lot of multiplication. It's a lot of addition. We are practicing core skills over and over again, but it's part of something that people will not maybe realize that they are practicing their mathematics. This perhaps would be a better way of practicing multiplication and addition than giving them maybe 20 or 30 sums to do. Moving on, let me get the next slide here. So next one I have got here is strategic competence. So again, one of Craig Barton's websites is ssddproblems.com. So I think that means same structure, different deep. So that's the image in the middle of the screen here. So this is the kind of thing you'll see on this website. So there'll be something in the middle. Here we have the fraction 3/5, and then there'll be 4 questions around the middle. In this particular instance, they relate to 4 different concepts in mathematics. So top left talks about writing a ratio. Then bottom left is talking about a pie chart. Top right here, I think is working backwards. I think 3/5 of a number is 60. What's the original number? And then it's a bit of shape and space in the bottom right. A square has side length 3/5 centimeter. What's the perimeter? So we start with the same starting points, the fraction 3/5, and then it leads to different places. We need different strategies to deal with the same fraction in different ways. The goal-free problems, .blockspot. Let me see if I can copy this into my browser here. So I think Pete Matic, Pete Matic runs this one, and it's a collection of Word documents. If I open up the first one here, let's hopefully the internet is still working over here at 5 to 5 in the evening. It says. So okay, so it's a collection of past exam questions, but the twist is here, the actual question has been taken out. It's been left open-ended. So question 1 here, Ewan has 48 white tiles and 16 blue tiles. The cost of each white tile is 2. The cost of each blue is 4. Well, what can we work out from this information? So this, I feel, is an important skill at GCSE level in those multi-step, multi-mark questions, where oftentimes, perhaps, students will leave it blank. They don't know where to start, and perhaps it'll be an easy mark to start off with, but people don't know how to reach the final solution, so they will literally leave it blank and move on. Well, maybe this is a good strategy at GCSE level. Instead of concentrating on the question that has been asked, to ask yourself, right, what can you work out from this information? Given this information in the question, what can I do with it? And oftentimes, if I can find a key into the problem, if I can find a place to start, that will lead me on to the correct path to the solution. So if I'm thinking of strategic competence, this one, the goal-free problem, would be the one to go with. And of course, we could easily envisage starting with any exam question and then just changing that final sentence to be, what can we work out from this information? So that's the goal-free problems. There's a final one here now, communication using symbols. In general, how we communicate in mathematics, be it writing solutions down or just working with manipulatives. So the MathSpot website run by Jonathan Hall is a free website, which is fantastic. If you haven't got physical manipulatives in the classroom, there are digital ones available. So here, for example, we see algebra tiles that can be used to solve equations. We have bar modeling, which can be used in ratio questions. We have 2 color counters, which are great to use with negative numbers. And then what else? We have Questionnaire rods and Dean's blocks, which would be great for place value in different bases. Perhaps we don't have to stick with base 10. We could use a different base to explore there. So that's definitely a website to have a look at if you haven't already done so. And then there's a relatively new one called Mathigon. I'll finish with this. If I can select the text here. So if I go into the Mathigon website, so this is another free website, which is full of manipulatives. So there are sections on the left. We've got geometry, numbers, fractions, algebra, and so on. So you could do a bit of tessellation. You could experiment with how shapes tessellate together. That could be something that we could be done there. There's the 3D solids section, so I can drop a cube, and then in the bottom here I can unfold it so then show the net for the cube, and then to fold it back up I can turn it around and so on. So that's maybe a good one for your net lesson. What else? There are number tiles, number cards, number grids. There are fraction bars. So I could, for example, show two halves here and create maybe, get rid of that one there. Maybe I can split off, then I can split these tiles. I could then show that 2/4, and I need to split that off as well. I can then show that 2/4 is equal to a half, perhaps. So there's different tools and techniques for fractions. Algebra, I could have a balance scale, and then I could drag a little weight here. I could put 2x on the right-hand side, and then perhaps I could get a number tile as a unit. So I can put 1 unit on the left, and then I can copy these. So let me say, how much have I got here now? 1, 2, 3, 4, 5, 6, 7, 8. Let me have one more. So let me put 9 units on the right-hand side. I need to tell the system then that these are balanced. I can click on the scale, click on balance. Then I have an equation here, 2x plus 1 equal to 9. I could then go on and discuss how to solve this equation. If I could take one off the left-hand side, it's now not balanced. I need to take one off the right-hand side to get the balance back going. And then I could perhaps then rearrange these unit tiles into a stack of 4 and a stack of 4, and that could be a visual way of noticing that x is equal to 4. So there's lots of things here. Probability and data. I could roll a die. I could even get 2 die, select them both and roll them both together. So hours of fun to be had on this website. There are spinners here, which I can spin around. I could change the number of sectors to different sizes. So again, there's lots of different manipulatives available on this website. As I say, I could spend an hour just going through this website. But I'm looking at the clock. It's 1 minute to 5. So I think it's time for me to stop sharing my screen. And then I will hand it over back to Sian.
Thank you, Gareth. Thank you so much to Gareth for running the session this afternoon. Quite a few examples and valuable information for you to digest and think about. Thank you all for listening and for attending this session. I hope you found it useful. I will sort out the recording and I'll email a copy to everyone over the next couple of days. Thank you.